In this video, I am incredibly fortunate to have Jordan from The Limiting Factor on the channel. We talked about Talga and Novonix future, NIO solid-state batteries, investing, and wrapped up the conversation with battery recycling. But before we begin, no, this video is not financial advice or recommendation for you to do anything. It's just general information for entertainment purposes. So, without further ado, let's go! From watching your interviews, we realized that your background is not in physics, but in organizational psychology. So I thought a really good place to start is, why did you go down the organizational psychology path?
Because I went, I'm from a small town, and there was a local university, and it was the only four-year degree they offered that I was interested in was something that was a combination of management and organizational psychology, which together is called organizational leadership. So it's not like I was like, ooh, that's what I want to do with my life. What actually happened was I didn't want to go to university. I could see that everybody's going to university. It's like, why would I want to do what everybody else is doing? And why do I want to go to university for 4 years and rack up all that debt and then come out the other end with basically it's just a piece of paper, and ultimately your ability to actually do things and create things and create value for people. That's how you make yourself a worthwhile person. There's this obsession with parents back in the 80s, 90s, and zeros that if my child doesn't go to university, then he's a failure. And it's like if everybody's doing that, it's of no value. You have to, if you want to carve out, you have to find a path that you do something useful that not everybody else is doing. I was like, I wanted to get a 2-year technical degree in like automotive or welding or constructing houses or something like that. And in the area that I'm from, you can actually take the last 2 years of high school that you have, and for half of each day, you can basically, it's the equivalent of going to a technical university, and you can graduate with the equivalent of basically a technical degree. So I was like, oh my God, this is free. So I won't rack up any debt. I really don't know what I want to do with myself yet. So, graduate with a degree that I can use to make money. And then after that, I'll figure out what I want to do. But parents had control of my curriculum. I didn't have any say over it. So they picked that. So what I did
I feel you. I feel you. That's an Asian thing as well.
Like, there's no sense in investing 4 years of your life and tens of thousands of dollars in something that you don't even know if you're interested in. So what I did was, everybody assumed it would be a waste for me to get a technical degree. I don't think it would have been. But the thing is, I was the type that I didn't have to study much in school, and I got straight A's. So I applied to a local university, which had relatively low standards. And I got a full ride scholarship, and I lived at home with my parents throughout university. And I finished my 4-year degree with no debt. So I at least achieved that goal. And then ever since then, I've been trying to work out. I've bounced around. I've done so many different jobs. I've always been trying to work out, all right, where can I provide value for people? Probably one of the most valuable things I've done is what I'm doing with my channel now.
So building on that point, actually, I wanted to ask you, looking back to 2020, what was your proudest achievement?
I would say my proudest achievement for 2020 was not putting my foot in my mouth too badly on anything. I did make a few mistakes, but my primary, I didn't want to mislead anybody, and I didn't want to give any people information that was so bad that would make their understanding of batteries worse. Because when I see most of what's being delivered in the media and a lot of the information out there and a lot of the hype that you see with companies, it's all giving people unrealistic expectations about batteries and giving them a warped perception of what's possible. And there's a lot that's possible, but what's claimed often isn't possible, and it's overinflated. And especially me as an investor, I want to actually know what is possible and who's overinflating their claims, so I know what to invest in.
I feel like one of the things last year that was so mind-blowing coming from you was your interview with Dr. Meng. I don't know if you feel the same way, but I've learned so much from that interview.
Yeah, I was just answering your question off the bat, and I would say I would agree. I think that would be the high point of the channel for 2020, because I went from somebody who didn't know anything about batteries to within about, I think, 8 months, having that discussion with Shirley Meng. And I felt like I was able to keep pace with her somewhat in that interview. I felt a lot of pride after that discussion because I felt like I didn't completely fumble the ball on it. And then I think for the people who watch my channel, it kind of validate the channel to see that I was speaking with somebody who is an expert, and we're kind of playing off of what each other's saying, and we're kind of like thinking along the same lines.
The validation is definitely there. And I think what it's on everyone's mind also is that your process of learning, going from 0 to 1 in like a span of 8 months for something that's so deeply technical was like crazy impressive. What is your process when it comes to understanding something so technical in such a short span of time? Because 8 months isn't that long. People dedicate like 5 years for stuff like this.
Hard work. There's really there's no trick to there is kind of a trick to it, which is the thing is, when you start a YouTube channel, you get people in the comments that start giving you feedback and telling you, all right, you're incorrect here, you're wrong there. So it kind of puts some bumpers on your knowledge. And also, when you reach out to people who are experts, you can say, all right, here's the videos I've made. This is what I'm attempting to do. And most of the people that I spoke with are like, okay, you're making actually an honest attempt at understanding this topic rather than just hyping batteries. So the fact that I was making an honest attempt to actually provide value for people rather than just make a buck off a YouTube channel, I think they saw that, and they were willing to devote time to speak with me and help me upskill, because I was honest about the answer when I said hard work is just lots and lots of hours. That was the key thing. But one thing that's really helped accelerate that by double or triple is having access to people to ask questions and bounce ideas off of.
Let's talk about something that we've been talking about for ages, which is stocks and batteries, especially in our conversation, with a focus on Talga and Novonix and some of the graphite companies that we've been talking a lot more about. The first thing, I think after Battery Day, and I know that you busted this myth in your video, but we should still talk about it, is graphite anodes are dead. I'll let you bust that myth.
Oh, yeah. So it's a funny one to bust, because in order to really bust the myth for individual people, like, everybody has their own set of assumptions. And in order to really bust the myth for a specific person, you actually have to have a conversation with them and find out, like, why is it that you believe that graphite anodes are dead? The broadest way to look at it in terms of graphite anodes is technologies usually, they don't just die, they carry on, and then the new technologies get built on top of that. So say, for instance, if there was a solid state battery that got developed tomorrow, well, you still have all these factories producing graphite anodes, and they're probably going to continue producing batteries with graphite anodes, because you already have all these sunk costs. The new technologies get built on top of the old. The place where I got that insight was my interview with Mark Thompson. He talked about this basic assumption that graphite anodes are dead as well. So I guess that's the first part of it. And the second part of it is, okay, we have these silicon anodes rolling out. Tesla's made it clear that they're going to 30% silicon, which means, I know, half to 2/3 of the energy density, or actually probably the best way to look at it is from a weight perspective. That means about half the weight of the anode would still be graphite. Well, this is a multi-year plan for Tesla, that 30% level, which is about half graphite. And those batteries will continue to be produced for years to come. So we're saying that, okay, so maybe you're going to need half as much graphite anode as you did before. But what Tesla also said at Battery Day is, we're going to be producing twice as many batteries in 2030 as the analysts expected. So, okay, yeah, so you're using half as much graphite anode material, but you're producing twice as many batteries, so you end up in the same spot. I mean, another way to look at it is that companies like Talga have anticipated increasing levels of silicon, so much so that they're actually developing their own silicon graphite particles. One more way to look at it is from a technical perspective. So one of the most challenging parts of using silicon in an anode is the expansion and contraction. There's a number of ways that you can handle that expansion and contraction, but one thing that helps a lot is having another material within the anode to help buffer those expansion and contraction stresses. And graphite serves that purpose. It not only buffers those expansion and contraction stresses, it provides energy storage at the same time, and it's relatively cheap. Not as cheap as silicon, but I mean, I think those are about 4 things right off the top of my head where graphite's going to be with us for a long time. And keep in mind that Tesla's accelerating towards silicon faster than any other manufacturer from my perspective. And Tesla's only going to be one part of the global supply chain for batteries. And there's multiple other companies that are behind Tesla are probably going to be using more graphite in their batteries for a longer period of time.
Do you think that other auto manufacturers will follow that trend of loading the anode with silicon? Or will some just maybe just skip that and try and go for solid state?
There's, I forget what it's called, some long German word. There's some board or advisory group in Germany, and they came out with like a roadmap for batteries. And this roadmap came out a while ago, and this is well before Battery Day. They were saying, okay, we're going to see stages of increases of silicon, because as you increase the silicon, you encounter different challenges. The entire battery industry has the same plan as Tesla, but it looks like Tesla might be 2 years ahead, I would say, of everybody else. Everybody's going to be doing this. And what's going to happen in the late 2020s is there's going to be a period of time where there's both high loaded silicon anodes and solid state. Now, the thing with batteries is, as we've seen with lithium iron phosphate and high nickel chemistries, you have different battery chemistries for different use cases. So it might be that the solid state are used in a different type of use case than the high silicon. Just because you have a new product doesn't mean the other one's obsolete. They just might find niches. One thing I noticed about anodes is that every manufacturer you talk to, they will give you the set of information that supports their point of view.
Yeah.
Not necessarily because they're trying to be biased, but that's because that's what they built their business model off of. So, and I found that I had to come to my own conclusion about how the anode market is going to develop, because I could not find a neutral opinion in the public space from an analyst. I did receive neutral opinions from individuals within the graphite industry, but I wanted to find somebody who wasn't in the industry that could provide a neutral point of view. But I never managed to find that.
Now that, we talked about silicon anodes, I think the first question I have is, can we do a quick recap on the performance differences between synthetic and natural graphite? And also, is it possible for a high purity natural graphite to have the same performance characteristic as the synthetic?
Okay, so I would say the key differences between the synthetic and the artificial is that if you take the very best of the best of each, or say the average material characteristics, then synthetic has longer cycle life and better performance, but it's much more expensive. Whereas the natural graphite, on average, it has lower performance, but it's cheaper. You can have a natural graphite product that outperforms a synthetic graphite. And that's why I said the average, or if you take the best of breed. And it depends on the use case as to what you should use. And as we improve electrolytes, I think there's less of a need for a really high-end synthetic product, unless you're going to be building something like a product for energy storage, which needs to last something like 10,000 cycles. But in most use cases, I think natural graphite is probably going to be just fine. It's going to be cheaper. It provides essentially the same amount of energy density. It has lower CO2 emissions. And to answer your last question, I don't think that we're going to see a high-end natural product outcompete a high-end synthetic product in terms of specifically performance. Manufacturers don't make sure their purchasing decisions based on what has the longest cycle life. It's made based on a number of decisions. What is the most economically viable for their product?
Yeah, I remember you and Dr. Meng talk a lot about cost performance ratios, and that's kind of where a lot of auto manufacturers are going to make their decisions on. So I think that's super interesting. And I wanted to build on that a little bit more. The way I understand this is that the input of synthetic graphite, which is needle coke, not the white stuff, but like the byproduct from petroleum, production, they have to compete with the steel industry for that. How will a synthetic graphite manufacturers navigate that environment? Because for me, it seems like there's a shelf life to that business line.
It's a conclusion I've come to as well, because the thing is, if you're basing your product off of fossil fuel byproducts, what happens when there's less of those fossil fuel byproducts and we continue to have increasing steel demand? And I never really got a fully satisfactory answer to that. There was some comments that these needle coke producers are accommodating the synthetic graphite market, and they're making materials available for it, so it should be less of a worry. But in the long term, past 5 years, it's pretty gray to me. Whereas natural graphite, I don't see it having that issue.
So knowing that the future of graphite anodes will be silicon loaded, how would Novonix catch up with a silicon graphite anode product line?
Yeah, well, they're working on one. I don't know, which you've probably seen in their bar chart and their timeline. And the thing is, they're partnered with Mark Obervak's lab in at Dalhousie University. Or yeah, Mark Obervak is, I think, considered an expert on creating silicon products for graphite anodes. I think they use a silicon metal alloy, which does have some promise. And some people have said it has the potential to have a super long cycle life, which is, I think, potentially why Novonix, I bet that's what they're pursuing, because if they're pursuing the long life in terms of the graphite, they're pursuing long life in terms of the electrolyte, it would make sense that they would pursue the silicon product that has the most promise for long cycle life applications. I don't know if Tesla's product can say the same. Yes, I believe Tesla's product will last for a couple thousand cycles, which is good enough for a vehicle. But if you're looking at long life energy storage, that might be what Novonix is tackling. And if they do tackle that, it could be very good for them and very good for the energy storage market if we're able to use high loaded silicon in energy storage products. It might be almost competitive with lithium iron phosphate, which I view as the best option.
Can I just ask, so what exactly is the difference between a silicon alloy versus the silicon loaded anode that we traditionally talk about?
I'm going to oversimplify this, but
Okay, that's fine.
I think it illustrates the point. Tesla is coating their silicon with a polymer coating. Silicon metal alloy is where you use a matrix of a couple different metals around that silicon particle to expand and contract instead of a polymer.
Okay. Also, it's just a different kind of
Yeah.
outside layer to contain it.
Yeah, it would be heavier because it's made of metal, but it might also be more durable.
If it's heavier and it's a metal, would that be more expensive then?
Yeah, it would be. I think silicon metal alloys would have less energy density than Tesla silicon. But the thing is, if you're comparing that to graphite, you're still an order of magnitude more energy density than graphite. So you're still well ahead, and it would probably be more expensive than the polymer approach. So overall, at the cell level, I don't know how much more expensive that would be. But if you're going for the energy storage market where you need tens of thousands of cycles, that becomes less and less of a concern. So yeah, I'm really interested to see what Talga and Novonix do. I think Tesla has picked the best option for them, and I think they've selected a technology which is absolutely brilliant. But there are other competitors in the space that may find niches.
Yeah, I personally find that, we talk about Talga a lot, and I think on top of right place, right time, I just feel like the decision-making of hedging their bets going into Town OSI, and then they have a solid state product as well, which is not that often talked about just yet, but knowing that this is the decision-making that they have, they're aware of the future while focusing on the near-term commercials. I think for me, that makes them beyond a traditional kind of like manufacturer.
I 100% agree, and it's part of the reason why I'm so passionate and interested in Talga and Novonix, because these aren't just your typical mining company. They're in the case of Talga, fully vertically integrated. In the case of Novonix, pretty well vertically integrated, but both of them have a very strong research backbone. And with a strong research backbone, that along with that comes the ability to innovate and put out other products. I'm glad that they're focusing on just regular stock standard humble graphite anodes, because that's where the money is right now. There's a lot of flash in the pan technologies out there that will develop over time and will be lucrative. But just because you see a solid state battery announcement or somebody claiming 100% silicon anode, that is far, far from a product that's ready for the market. And I do think they'll eventually hit the market, but it's probably going to be 6, 7, 8, 9, 10 years before it's at volume. And it's at volume where you make the money. You don't make money off of having the highest energy density battery cell. You make money off of having the cheapest battery cell.
Let's talk about solid state now, because now that you mentioned it, let's talk about it. NIO have announced their sedan. It will come with a 70 kilowatt or 150 kilowatt solid state battery. And they're saying that they can release that in early 2020. Who in the world are capable at creating solid state batteries at scale?
The type of solid state battery they're claiming isn't pure solid state, as I understand it. It's more of a semi-solid jellyish battery. So like it's not pure solid state. And the reason why having a pure solid state battery is so important is because with a typical battery, God, there's a lot of reasons why a solid state battery is so much better than a battery that even has a few drops of a liquid electrolyte in it.
Mm.
Liquid electrolyte is the thing in a battery that is part of the reason why they're so flammable. It also adds a manufacturing step, so there's the cost there as well. I mean, those are just two factors as to why. There's a pure solid state battery, which is called an all solid state battery, which is the holy grail. And there's a battery where people have kind of cheated and cut corners to make the solid state battery work.
Okay.
And my understanding is that's what NIO has. That's purely feasible, and there's a lot of companies out there, I think, including QuantumScape. QuantumScape uses liquid in their battery. I think, as far as I know, there's only one or two companies that are actually producing, maybe even one. I think it's called Blue Power or something like that. They actually have a commercial solid state battery that they're selling. They claim that they're the only one. And I know Solid Power, they have a manufacturing line, but they're not producing them commercially. They're just testing their solid state batteries. And Solid Power is one of the furthest along. Toyota is more secretive, but Toyota's been working on their solid state for, I think, I don't know, 12, 13, 14, 15 years, something like that. They've been working on solid state for a while. And I think Solid Power and Toyota, I think one of those two will be the first to create an actual solid state battery, but they're not on the market yet. No, a solid state battery that we'll see in volume, because Blue Power, they do make products, but I don't think they're doing a extremely high volume. I don't know if I answered your question. I go off on tangents sometimes.
You did, and then some more, which is great, because part of my question that I also wanted to ask is Toyota have actually said that in 2021, they should have a vehicle with a solid state battery. So from what you said, it's perfectly rational to think then they can produce a certain set, maybe a certain volume at least of cars with solid state batteries.
Yeah, and it's worth coming back to NIO because I have a bit more.
We'll come back to them
them
because I still have more questions on that.
Okay, so it's perfectly reasonable, I think, out of anybody to make the claim that they have a solid state battery ready for production. It would be Toyota, because they've been working on it for so long, and they have, my understanding is, hundreds of patents on solid state batteries. However, it's the reason I'm not a big fan of solid state yet is because it's so expensive. And I have a feeling that this is going to be an expensive vehicle that they put it in, and it'll be interesting to see what kind of performance they get out of it.
Yeah, so that's what's interesting to me, because then what would be the cost of that car? Because that car will be like basically a luxury car. And what's like, going back to NIO, what's really interesting about the NIO model is battery as a service. It's all about making EVs more affordable, because you're essentially buying the car without the battery, and then you're essentially renting the battery. A big part of that challenge is having a lot of batteries in the station so that you can swap them out, whenever you need to. So the next question I have, going back to NIO solid state battery claims, is so with the whole cycle life, especially when it comes to solid states, how many cycles can you get in before you basically have to, send it back to the factory and be like, hey man, give me whatever that's left, and then let's build another one?
It depends on how much people abuse the batteries. I imagine if it's a battery as a service kind of thing, they might get a bit more abuse, because people are like, all right, well, this isn't my battery. I can just go get a new one anytime I want. But let's assume that they have roughly the same amount of abuse as a typical lithium ion battery. The batteries would still last for, I don't know what type of batteries they're using or what type of chemistries they're going to be using, but I would like to think they would last at least 200,000 to 300,000 miles. It's not something that I consider useful. To me, it's like, imagine you have a company where most of your product is sitting on the shelf most of the time. It's that inventory problem where you don't want stuff on your shelf. You want to be making money off of it. You want to be cranking it out, putting it out the door. And I don't even know how much money they can make off a model like that. It seems like a waste of engineers. Those engineers could be put to use doing something much better, I think.
Okay, so I want to go back and focus on stocks a little bit, but this time beyond batteries. Now, I know you talk a lot about A2. We talked about A2 in the past. We talked about zero in the past. And we talk a lot about how you're looking for that 10x opportunity, right? So if you can share some of your top 10 holdings of your 10x opportunities, I would love to know. But beyond that, what do you look for in a 10x opportunity?
where to start. I pulled up my phone because I wanted to look at what I currently have. The thing is, currently I'm in the process of shifting what's left of my New Zealand assets to U.S. accounts because I plan on moving there later on this year. So I just cashed out of 3 of my Australian stocks yesterday, which were A2 Milk, Volpara, and European Metals Holdings. So what I have left currently, I don't know what I'm going to do with that money yet, what I'm going to buy, but right now I have Bitcoin, Tesla, I have Archimoto, Planet 13 Holdings, and Talga Resources, which are all held in a US account. Everything's in US dollars there now. The thing I'm running into now is the first few years that I was investing between 2016, 2020, there's so many deals on the market, so many companies that I thought were undervalued, particularly in the battery space. I was like, this is going to be like a square wave when the money starts moving into battery stocks. And I saw like every battery stock appeared to me to be a 10x opportunity. But now we're in the space where it's like, ooh, most of these companies have had their values pumped recently. I've seen such a flurry of material supply agreements with a lot of the material suppliers. And of course, Tesla's been revalued. I don't see many 10x opportunities in the space. There's several of them that I see in the long term that they could do 10x, but in the short term, I like to find a company that can do 10x within like 5 years. And I'm not seeing anything in the space at the moment. And I've noticed that with a lot of my stocks that aren't battery related stocks, they're kind of languishing, where previously they had a march up and away, and that was continuing, and now they flattened out because everybody wants to get into battery stocks. And I have a feeling that the way that money sloshes around the market, that it's going to return to companies like Volpara and A2 Milk at some point.
Is there a particular industry that you're looking at right now that you believe will have a 10x opportunity in the near term?
One thing that interests me, what I don't know enough about, is the genomics industry. I wouldn't know how to pick a company, and I spent so much time on battery research that I don't have time to dig into those. At the moment, there's nothing that I'm interested in investing in that I'm really passionate about, like I was 6 months ago.
Yeah, same here. Because I remember 6 months ago, we were talking about Bitcoins. We were talking about the whole mining space as well, because it's still under discovered, which is great. I wanted to finish up our chat with recycling. What battery chemistry or what types of batteries are the most recyclable and will potentially be cost efficient?
I think it depends on a few things. I would say the high nickel chemistries are the most viable for recycling because they contain the most expensive elements. Like a lithium iron phosphate, you can get the iron that goes into those for $6 per kilogram. And I don't know if you'd be able to get it much cheaper directly out of recycled battery material. I think you could get it cheaper because it's not like you have to go out and mine it. It's just a pile of batteries and you have to throw them in an incinerator. Nickel seems like the best candidate for recycling because of the value of the materials in it. Now, what I see happening when recycling really kicks into gear is that it's going to drive down the cost of batteries and battery materials significantly. The raw materials, as Tesla showed in their Battery Day presentation, in a battery are about 10 times the concentration that you'd find in an ore in the ground. So if it's 10 times as concentrated, I would like to think that you'd be able to extract those materials significantly cheaper and drive down the cost of batteries even more. It's I wouldn't call it a flywheel effect, but a virtuous circle. Once we start having enough batteries being recycled, it's going to drive down the cost of raw materials. And that's why I think Tesla, for their process, said they're going to be able to directly consume nickel. I'm assuming they meant like nickel oxide materials there, because if their process can directly consume nickel oxide, they can directly take recycled materials, boop, and then just pop it back into the cathode production line.
Yeah.
And it's one of the greatest underappreciated things about Battery Day, because currently sulfides are used in battery production processes because they're water soluble and they're broadly available. But to create a sulfide, there's an additional production step in there. So I don't know how Tesla is able to take a material that's not water soluble like nickel oxide, dump it into these tanks with fluid, water, etc., and turn it into a finished cathode material. It's still a mystery to me, and I've done a deep dive into it. The only way I can see that they might be able to do that is to convert the nickel into something else. But they might have some magic there that I don't know about.
Magic indeed. And I was actually wanted to ask you one more question around structural batteries. Would structural batteries then impact the future recyclability of batteries?
It depends if they've designed the product from the beginning to be unmanufactured, because that's basically what you're doing when you're recycling. You're tearing something apart that's been manufactured. And the amount of inert material that's in Tesla battery packs continues to go down. It might be a situation where they might be able to take this battery and just melt it down like the entire battery pack. I don't know. I don't know if that's even technically feasible, but currently Tesla battery packs are there's so much material around those battery cells, and those battery cells are so entombed in other materials. I don't see how a structural battery pack would be more difficult to disassemble than Tesla's current battery packs. Especially since, yeah, the structural battery pack, it sounds like it's a more monolithic thing, and it is. However, there's actually less materials in that structural battery pack. You don't have those modules that you have to break the cells out of. There's less materials to tear away and tear off. So I don't have a strong opinion yet on whether the structural battery pack will be more difficult to recycle, because currently the battery packs are difficult as hell to recycle. And I don't see how it could get any more difficult, because it's not like you can go in and just, take a screwdriver and pull apart one of these Tesla battery packs. You have to get in there with a chisel and chainsaws and break the thing apart. So, and I don't see that the structural battery pack is any different. I think the structural battery pack is just, it's going to contain less plastic and more metal structural materials. And that's why I say, well, why not just find a way to just melt it down? You'd still need to discharge the cells. One thing I further to say about recycling, I think the video that you sent me about recycling those products, it used a process. Was it chemical? A chemical reduction process?
Yes. It wasn't.
Okay.
It wasn't an incineration.
Okay, well, an incineration process would be completely different. I don't think you'd have to systematically deconstruct the battery cells to that level.
Just throw the whole thing in.
I need to look more into it. Maybe Tesla has decided that, well, it's not worth tearing these things down to the individual cell and breaking out each individual cell so then we can chemically reduce them. Why not just throw them into a furnace and burn the whole thing up and collect the materials that way? Yeah, you'd be able to collect less materials, but it would require a lot less prep, a lot less chemicals, a lot less of everything. It seems like it'd be a simpler, cheaper process. You just wouldn't get as much material out.
Yeah, I think you just have to pay the price when it comes to higher heat, higher carbon footprint, potentially, because you're burning the entire battery in flames and then reducing it down to the bare elements. Yeah, I'm just really excited by the idea that, maybe renewables isn't that far away when our planet is completely powered by renewables.
Yeah, I was saying this to people a couple of years ago. It's like, in terms of the technology, it's a solved problem now. Even with like Model 3 level technology that Tesla had a couple of years ago, that'll bring us a long way to decarbonizing things. But from what they released on Battery Day is what will accelerate the world's transition to sustainable energy. They revealed basically the machine that builds the machine that'll do that. So I think we're well on our way now. It's a solved problem. It's just a matter of how quickly we can scale these things. And I'm so looking forward to, like, when I'm recording a video, not listening to these loud cars and motorcycles going by, and just all the noise it creates and all the air pollution. It's like, okay, if you put the global warming thing out of it, these things are just like spewing toxic fumes and making our cities smell bad, corroding our buildings, corroding our lungs, etc., and making lots of noise. It's really primitive technology that we're currently using. And that's why I originally invested in Tesla. I thought, like, all right, there's a chance that I could lose all my money in Tesla when I originally invested. And then the more I looked into it, the more I was like, oh, actually, I'm not going to lose my money. I'm going to 20, 30, 40x my money over time. So that's another one. I think, could Tesla 10x? What's the current market cap? I don't think Tesla can 10x
not
by
here.
2030, but I do think they can 5x from here by 2030, maybe even earlier.
I appreciate your time a lot, and I've learned so much from you, and I'm hoping to continue to learn from you. So thanks for your time. I appreciate it, Jordan.
Yeah, thanks for having me. As always, it's good having a conversation with you.
I hope you enjoyed my conversation with Jordan. I've learned a lot from him, and I will continue to learn from him. So if you have learned something new, consider gently smacking that like button right there. Subscribe to my channel for more videos like these. And until next time, my name is David. Otto will always do the honors, and see you very, very soon.